theorems. We're going to learn Rolle's theorem and the mean value theorem. They are very, very important. You will need to memorize them. You'll need to know them word for word and know what they mean word for word. So that's what we're going to do is work on these two theorems today. Rolle's theorem says if a function is continuous on a closed interval a to b, and you need to know all of these things. So we have a continuous function on a closed interval from a to b. So I get from a to b, and it says that f of a equals f of b. So wherever f of a and f of b are, those are equal values. So the y value of a and y value of b are the same. Remember, it's differentiable. Then there is at least one point C in that interval AB where the derivative is 0. Would you agree that to get from A to B without having any sharp corners, the derivative somehow will have to be 0 somewhere? Now, what if it's a straight line from A to B? The derivative is 0, right? Horizontal line, the derivative is 0. It could do something like that. It could do something like this. Right? But at least one point the derivative is 0. The rate of change, the average rate of change between f of a and f of b was 0. Right? There was no change. If the average rate of change is 0 somewhere, the instantaneous rate of change has to be 0. That's what Rolle's theorem says. Any questions about Rolle's theorem? Rolle's theorem is a special case of the next theorem, which is called the mean value theorem. Mean value theorem actually is the only one that AP Calculus makes you memorize, but there are a lot of problems that knowing Rolle's theorem makes them a lot easier, so we are learning both. But the mean value theorem says that if f of x is continuous from a to b, continuous on the closed interval, differentiable on the open interval, then there is at least one point C in a to b such that the derivative at C is equal to f of b minus f of a over b minus a. Someone tell me what in the world f of b minus f of a over b minus a is. It's the average slope, right? From a to b, it is the slope. So it's giving you, this thing here is giving you the slope of this line. Agreed? Then the mean value theorem says at some point along that interval, the instantaneous rate of change, or the tangent line, has to be parallel with it. Now let me give you a real-world application of this so this makes a little bit more sense. So if I drive from here to Fort Smith with no stops, no, I don't stop, I don't do anything crazy, don't turn around, just drive straight continuously from here to Fort Smith, and I average 60 miles an hour, did I speed at some point? Had to, right? Maybe not the whole way, because it's on 80 for a while. I don't know. Right? But would you agree at some point I had to go 60? If I averaged 60, at some point I had to go exactly 60 miles an hour? That's what the mean value theorem says. If I average some rate of change, at some point along the curve I have to equal that rate of change at an instantaneous rate of change. Does that make sense? So, a couple of things that are very important. We have to have a continuous function. If I don't have a continuous function, I may have somewhere to asymptote in between, which would totally mess up the rate of change discussion. Has to be continuous. Otherwise, a sharp corner could throw it out. I could have a constant rate of change on the left and a constant rate of change on the right that aren't equal to the average rate of change. So it has to be continuous on the closed interval AB. It has to be differentiable on the open interval AB. If that is the case, then there is at least one point in AB such that f prime of c equals f of b minus f of a over b minus a. These two theorems will be on your next gateway exam, on your next mastery exam. So you will have to memorize them, but don't wait until that exam to memorize them. Start trying to memorize them now, and you need to know them now. Word for word. Word for word. Both of them.
What's the next one?
I don't know yet. I'll let you know before the semester ends. Yes. And I will give you a I'll give you the number 1 copy so you can try it. It is coming up pretty soon, next Monday, Tuesday. This is the last lesson before the next test. Okay, so mean value theorem in words says the average rate of change on an interval is equal to the instantaneous rate of change at some point on that interval. Of course, for this to hold true, the function has to be continuous and differentiable. This is the words to the mean value theorem. Why is Rolle's theorem a special case of the mean value theorem? I said the AP Calculus doesn't make you do Rolle's theorem because it is the mean value theorem. Why? At 0, right? If they're the same, the slope is 0, right? So it's just saying the average rate of change is 0, so the instantaneous rate of change would be equal to 0. So, some examples. Determine whether Rolle's theorem can be applied, and if it can be applied, find the values of C in the open interval AB such that f prime of C equals 0. If Rolle's theorem cannot be applied, explain why not. What are some things that have to hold true for Rolle's theorem? Continuous and differentiable. So let's look at the first one. Is it continuous? What am I even looking for to decide if it's not continuous? Wholes, asymptotes, denominators, square roots, weird things like that, right? Is this continuous from 0 to 3? It's polynomial, it's continuous everywhere. Is it differentiable? It's polynomial, it's differentiable everywhere. Right, polynomials are nice. What else has to be true for Rolle's theorem? F of 0 and f of 3 have to be the same. So, a couple of things I'm noting. F of x is continuous. F of x is differentiable. F of 0 is 0. F of 3 is 0. So, can Rolle's theorem be applied? Yes. Okay. If Rolle's theorem can be applied, find all the values in C of C in the open interval AB such that f prime of C equals 0. So, find the derivative, set it equal to 0. So we're finding relative extrema is or critical points anyway. Set that equal to 0, find the value of C, find x value that makes that equal to 0. C equals 3 over 2. I appreciate it. Any questions about that one? So Rolle's theorem does apply, and C is 3 over 2. Let's look at the next one. Is the next one continuous? Can you plug anything you want into x? Yes, so it is continuous. Is it differentiable? Maybe. How could we find out? Find the derivative. Is there anything that makes that undefined? 0. Is that between -8 and 8? So Rolle's theorem does not apply. I can't even try to use Rolle's theorem. Now, does that mean there's not a place where the derivative equals 0? There could be. I just don't know. Rolle's theorem tells me nothing. There still could be a place where the derivative equals 0, but I'm not guaranteed that. Yes?
So why is
Why is it not differentiable? This is the derivative, right? Plug in 0. What do you get? Which is? There is no derivative at 0. So, not differentiable at 0. So essentially you check to see if the derivative is continuous. Well, I actually didn't plug 0 in. I looked to see what would make this not, what could I not plug into this? So I had to come up with the 0. Does that make sense? And since the x is on the bottom, I plug 0. Any questions about that? Okay, what about the next one? Okay, now, you don't really even know how to take the derivative of an absolute value function, do you? Which part of this is very important that you know? The picture of the absolute value function. If it's a v, it has a sharp corner at 0. 0 is between -1 and 1. So, no Rolle's theorem. So sometimes we're going to figure that out algebraically by taking the derivative and looking at it, because I don't know what x to the 2/3 power looks like graphically. It's not one of the ones I've memorized from pre-calc. However, the derivative of the absolute value of x minus 1 is something that I don't know how to find the derivative of analytically. By the way, if you wanted to find that derivative analytically, you'd have to rewrite h of x to be two separate linear piecewise functions. And then you do the derivative that way, and then the derivative at the break point would be undefined because it's a piecewise function. Any questions about this? Okay, very similar question. Determine whether the mean value theorem can be applied on the closed interval a to b. If the mean value theorem can be applied, find the c, guaranteed by the mean value theorem. Can it be applied? What's the c that the mean value theorem guarantees if it can be applied? To determine whether the mean value theorem applies or not, it's actually a little easier because Rolle's theorem had three conditions: continuous, differentiable, and f of a equals f of b. Mean value theorem only has two conditions: continuous and differentiable. The two endpoints don't have to be equal. So to see if the mean value theorem applies, all I have to know is the function continuous and is it differentiable? Is sine of x continuous? Is it differentiable? No. So sine has no holes or asymptotes, and cosine has no holes or asymptotes. So it's continuous and differentiable. Mental note that. So mean value theorem does apply, which means b minus f of a over b minus a equals f prime of c at some c value. So to find out where that is, y'all remember that question on your test? Last test where I had you do this, you just didn't know what you were doing. It said find the slope of the secant line and when it equals the slope of the tangent line. I was having you do the mean value theorem. You just didn't know what the mean value theorem was yet. But so f of b minus f of a over b minus a, f of 0, or sorry, f of pi, wouldn't matter, it's only 3.6. F of 0 over pi minus 0 equals f prime of c. Well, f prime of c would be cosine of c, right? So we're finding when does f of pi minus f of 0 over pi minus 0 equal cosine of c. Sine of pi, what is the sine of pi? 0. Do you still need to know that? What about the sine of 0? Could I have used Rolle's theorem? Could have. It didn't ask me to, but I could have. If you noticed, that would have saved you a little time. If you noticed f of 0 and f of pi were the same, you could have just used Rolle's theorem, wouldn't have had to show the secant slope, but that's okay. So I want to know when does cosine equal 0 from 0 to pi. Pi over 2. Now I know cosine equals 0 a lot of places, but I'm only looking from 0 to pi, so c is pi over 2. Any questions about that one? The mean value theorem can be applied, and the c that's guaranteed by the mean value theorem is pi over 2. So the average rate of change, and just a visual, this is not something you will need to do, but from 0 to pi, the average rate of change was 0. We found that the slope is parallel at pi over 2. The average rate of change is equal to that instantaneous rate of change at pi over 2. Say that again. We had to find c. It just said find c.
So knowing the location of arbitrary does it really mean that it has places that lost?
Most of the time you're not going to be able to just know, but I would say if you get the answer right and then explain how you knew it, that you'd probably be okay. As long as you put it in. Now the justification would be a little easier out this way, but I'm not saying no. You could probably decide. Okay, let's look at this one. Is it continuous? Where is it not continuous at? Is that between -2 and 3? So the mean value theorem does not apply. The shorthand for mean value theorem, very similar to the intermediate value theorem, is MVT. Any questions about that one? Those are easy ones if that really is the question. Okay. Is x cubed plus 2x continuous? Is it differentiable? It's easy because it's a polynomial. Those are always continuous, always differentiable. So I'm going to do h of 1 minus h of -1.
Does it matter if you do just diagonal minus
As long as you do the same thing on the top and the bottom. H of 1 is 3. H of negative 1 is negative 3. Is that right? Yes. Hold on. Negative 1 minus 2.
Oh.
Negative 3? Yeah. Make me question myself. 6 over 2, which is 3. And that should equal h prime of c. What is h prime? I'm going to call it 3c squared plus 2. Doesn't really matter how you do that, but if I call it h prime. And so I would get 1 equals 3c squared, subtracting the 2 over. So 1/3 equals c squared. And so plus or minus 1/3 equals c, almost.
B plus or minus square.
Oh, sorry. Thank you. The c, it just is h prime of c. So h prime of x is 3x squared plus 2. So h prime of c is Hey, calm down. Okay. Almost. I do need to go back up and notice that interval -1 to 1 are -1/3 and or -1 over the square root of 3 and +1 over the square root of 3, both between -1 and 1. Is there a chance you get an answer that's not in that interval? If you get something that's not in that interval, cross it out. We are only looking for c values between -1 and 1. Now I did hear, hey, rationalize. You need to know how to rationalize. The good thing with AP Calculus is they will accept any correct mathematical form of the answer, so you have to rationalize. You do need to be able to pick it out on a multiple choice answer if they say radical 3 over 3 and negative radical 3 over 3. So you need to be able to do it, but you don't have to anymore. We've grown up. Any questions about that? Okay, this is an example of a mean value theorem pulled from an AP exam. This is the 2004 exam, number 3. This is the exam I took. I mean, yes, because I taught it like 4 times, but no. Other than that, I don't remember. I remember one question from my AP exam. It was one that my teacher didn't teach. It was the first year that it was on the AP exam. It was a topic that was new to the AP exam. It was an open response, a full open response problem.
And did you remember it because you're mad?
Yes.
Did you just leave it blank or did you just make a bunch of stuff?
I did something, but practically couldn't. And it's a really easy topic. It was just something. It was new to AP Calculus, and my teacher didn't put a lot of emphasis on the AP exam. He was an excellent calculus teacher, but at the time you had to pay for the exam. Very few people even signed up to take it. It just wasn't the same as it is now. And so he wasn't real concerned with whether he taught the AP exam or not, you know. But anyway, he said, "Oh, that might be on there, but I don't think it will be." So, and then it was an open response problem. I'll give you a minute to write this down, read it, and we'll go from there. You have 3 homework assignments we're going to be working on over the next few days. This first thing that I'm passing out is actually what's due tomorrow. Okay. No. This single page each piece of paper is supposed to do tomorrow. Don't act like I just tell you. There are 8 There's really only 8.
They're all full alphabets. We got
I would almost argue that I could do less homework in calculus than I did in trade.
You don't get students that don't know like
Okay. So this worksheet that's coming back is due tomorrow. Worksheet that's coming back now is due tomorrow. Okay, did everyone get that worksheet due tomorrow? Tomorrow will be mostly a work day, minus whatever we don't get finished today, and then we'll probably do a few review questions every day throughout the week. But for the most part, we'll have some work done tomorrow.
So can we work on this?
No, I want that one done tomorrow. I want the one you have now done at the beginning of class tomorrow. This mean value theorem part 2 is due on Wednesday. Mean value theorem part 2 is due on Wednesday. Okay. Mean value theorem part 2 is due on Wednesday. One more thing. Due on Thursday. AP packet numbers 1, 2, and 3 are due on Thursday. We will also be working on other portions of the AP packet, but 1, 2, and 3 are due on Thursday. Well, not for the week. We will finish the AP packet. I'll probably start signing. Friday, because we're testing. We should probably do the AP packets. Really quick question. The exam you took last time. AP packet important? Yeah. There were 2 problems identical off of it. Don't notice that? 2 problems on the test that were on the AP packet. Should you do it?
I also don't remember
In the right direction.
Numbers 1, 2, and 3. This is due Thursday. Yes, only numbers 1, 2, and 3 as far as due Thursday. I will assign more this week as we go. But for now, your assignment is numbers 1, 2, and 3. Now you're welcome to work past that, but start with 1, 2. Okay, so this is an AP example. A test plate, y'all paying attention? A test plate flies in a straight line with positive velocity, v of t in miles per minute. I'm talking. Their time is in minutes. V is differentiable. And selected values of v of t from 0 to 40 are shown in the table above. Based on the table, what is the smallest number of instances at which the acceleration could be equal to 0? Now, a couple of things I want to go through. Reminder, if something says a function is differentiable, what does that mean about it? Has to be continuous, right? Differentiability implies continuity, right? So is this function continuous and differentiable? So we can use the mean value theorem, we could use the intermediate value theorem, it opens up a lot of different theorems just because it's continuous and differentiable.
Yeah.
We have a function that's v of t, that's velocity. Does anyone know, physics people maybe, how we would get to acceleration. So velocity is measured in miles per minute. Does anyone know what acceleration is measured in? Miles per minute per minute? Doesn't that sound like a slope of a slope? So if this is the first time you've ever heard that, acceleration is the derivative of velocity. It's going to be big to you. So acceleration is the derivative of velocity, or the rate of change of velocity. Write that down.
Acceleration.
Yes. So based on the values in the table, what is the smallest number of times at which the acceleration could be 0? So we're talking about the derivative of this being 0. So here's where it's really nice to know Rolle's theorem. This is a real AP question. What has to happen between those 2 points? The slope has to be 0, right? What has to happen between those 2 points? Slope has to be 0. Everyone agree?
Yes.
So what's the smallest number of times that the acceleration could be 0? 2. Justify. We hate that word, right? So, V of t, what do I need to say if I want to use Rolle's theorem or the mean value theorem? It is continuous and differentiable. V of 0 equals V of 15, which equals 7. Right? Therefore, V prime of t, or V prime of c, that will work, equals 0 for some c. You can either say between 0 and 15, or you can say this symbol means an element of, or in 0 to 15. Remember, we said V prime is acceleration. So we know the acceleration is 0 somewhere between 0 and 15. Do what? So you're not speeding up or slowing down.
Okay.
Constant velocity. Okay, any questions so far? Am I done?
No.
But all I have to do is kind of this sentence it again, right?
Yes.
Except I will say V of 25 equals V of 30 equals 2.4. Therefore, now, the AP reader is going to want to know, well, how do I know that? By what theorem? By Rolle's theorem. Now, if I had used the mean value theorem, it would have looked very similar, but I would have had to show a slope. Or I would have had to say the slope, the average rate of change between 0 and 15 is 0. Do you see why Rolle's theorem was really nice to know? AP does not make you know Rolle's theorem, but they will accept Rolle's theorem. So it is good to know. The AP packet. Did anyone get extra AP packets? Will you slide these over this later? I knew there would be extra somewhere. Okay, we will do another AP problem tomorrow in class. So, quick reminder, mean value 1 is due Tuesday. Mean value 2 is due Wednesday. AP 1, 2, 3 is due Thursday. So you can tell we don't have a lot left to cover. Again, I'm going to do a review PowerPoint as well. So we'll have those 2 things, and then you'll have some more time tomorrow. Also, we will grade F, F prime, F double prime. If you had any questions, you have a